Hello viewers, welcome to Exploring Technologies. In this video, I will explain the time series prediction using Adaptive Neuro-Fuzzy Inference System, that is ANFIS. Before going ahead, let me show you the contents of this video which I am going to cover. First, I will give the introduction to this time series prediction. Then I will explain the ANFIS for time series prediction. Then I will explain the Mackey-Glass chaotic time series that is considered as a benchmark problem. And then I will explain the algorithm for the time series prediction using ANFIS. After that, I will give the MATLAB implementation for this and I will explain the MATLAB code, and in the last I will explain the result analysis. So let me go ahead, but before going ahead, I recommend you to watch following my two videos. The first one is about the fuzzy logic controller. In this video, I have explained its theory and the MATLAB implementation. If you go through this video, you will better understand the basics of the fuzzy logic and the fuzzy logic controller. So that will definitely help you to understand this current video. And the second video is very important to understand this current video because all the basics and the theory of ANFIS I have explained in this video. I have also shown the MATLAB implementation, so that will help you to understand this current video. So I strongly recommend you to watch my following two videos before this current video. So links are given in the description, so you can directly jump over these videos. So now let me go ahead. So let's see what is the time series and time series prediction. So the time series is a sequence of observations recorded at the regular interval over the time. For example, the recording some weather data such as temperature, precipitations, pressure, etc., recording the stock market, recording the retail price of some commodity like gold price and the petroleum price. So the time series prediction is a technique to predict the future values based on the previous recorded values. So it definitely help the pupil to manage their business goals. So there are several methods to predict the time series data. Some are statistical while others are based on the neural networks, the machine learning. So now let's see those methods. So there are, as I said, several methods which are used for time series forecasting, such as linear statistical methods and the methods which are based on the neural networks. So the statistical methods include popular one, the autoregressive, AR, pure moving average, MA, exponential smoothing, and the combination of AR and MA, that is ARMA or ARIMA. So the main disadvantage of these linear methods is that they capture only the linear correlation and do not consider the non-linear patterns hidden in the data. So that is the main problem. So to overcome this, some non-linear methods such as bilinear model, threshold autoregressive TAR, and the autoregressive conditional heteroscedastic arc models have been used. But they also show the problem because they are very limited to the general forecasting problems only. So now let's see the neural network based models. So the neural networks, which are the non-linear models, are capable of getting non-linear patterns that exist in the input data. So both feed-forward and the recurrent neural networks can be used, but it is found that RNN are better in giving the accurate results. So few people also use the combinations of statistical methods and the neural network based methods. So one such combination that is very popular one is the combination of ARIMA and ANN, as proposed by Zhang. So GP Zhang, that is a research paper proposed by him, the time series forecasting using a hybrid ARIMA and the neural network, published in Neurocomputing. So you can access this research paper for more details. So some popular neural network based methods are ANFIS, RNN, that is recurrent neural network, and LSTM, long short-term memory. So LSTM is also a very popular tool in machine learning. So probably in coming videos, I will explain it. So here in this video, I will explain only the ANFIS based time series prediction. So let's see what is ANFIS. Although, as I said in the previous video, which I have shown in the beginning of this lecture, and I recommended you to watch that video because the basic theory I have already explained in that video. But here I'm just taking few lines just to recall what is ANFIS. So ANFIS is a neuro-fuzzy system that combines actually the advantages of both fuzzy systems and the neural network. So it utilizes the learning ability of ANNs and the data uncertainty handling capability of FIS. So it is more transparent than ANN, which use both numerical and the linguistic inputs. So ANFIS shows the ability of adaptation, nonlinearity, and the rapid learning. So Zhang and Sun demonstrated the suitability of ANFIS to predict the time series feature values in their research paper, and that is a research paper, Neuro-Fuzzy Modeling and Control, published in some IEEE proceedings. So you can search this in Google and you can access this paper, very important one. So Zhang and Sun used actually the chaotic Mackey-Glass differential time series, so which is considered as one of the benchmark problem for time series prediction. So now let me explain the algorithm of the time series prediction that is based on ANFIS. So here we have taken the time series, which is the Mackey-Glass differential equation, also known as the AMZ equation. It is given by this equation, differential equation, x dot, that is a derivative of xt, and when this differential equation is solved, we get the solution xt. So we have taken the 1200 samples of the solution for the following initial condition, and the value of tau is taken as a 17. So the solution is obtained using the fourth order Runge-Kutta method, and this is the series you can see. So these are 1200 points. You can observe the chaotic behavior of the series. It is not a periodic, okay, it is not deterministic, it shows the randomness. So you cannot see any repetition of the values. So obviously it's a chaotic series. So now the goal here is to predict the future values on the basis of the past values of this time series. So now let us consider the past values of this series till some point up to the t, and to predict the future values up to the point t plus p. So to achieve this, we have to create the mapping from d points of the time series which are spaced at the delta. So that is xt minus d minus 1 into delta, xt minus delta up to xt. So these are all previous values of this series, and they all are mapped to these feature values xt plus p. So let's see how it is possible. So many authors have used such mapping. So we are taking the similar one. So to match the results, we are taking t equal to 4 and delta or p equal to 6. So p equal to 6 means we are going to predict the 6 future samples xt plus 6. Okay. So we have total 1201 points of MG series, as I have just shown you in the previous slide. So from index 1 to 1201. Out of which 1000 points are selected for training. So these 1000 points are taken from the index number 118 to 1117. So out of these 1000 points, the first 500 points are taken for the ANFIS training, while the remaining 500 points are taken for validation. So this is my total time series from the index 1 to 1201. And we are taking only this section of the time series for the training. I mean from t equal to 118 to 1117. Let me tell you, as I'm using the MATLB for the programming, so index starts from the 1. Okay, so if you are using another programming languages, then the index will start from the 0, may start from the 0. So for mapping, following previous values of data series xt are taken for ANFIS training. So I have written this generalized relation. So we'll take xt minus d minus n into delta for n equal to 1, 2, 3 up to the t. So we have to take these values, previous values of the series for ANFIS training. So as we are taking d equal to 4, so this equation becomes xt minus 4 minus n into delta for n equal to 1, 2, 3 and d is 4. So 1, 2, 3 and 4. So total 4 previous versions of this xt we will take as input for ANFIS training. So let's see how. So expanding this for n equal to 1, 2, 3 and 4, we get following terms. So substituting n equal to 1 So this is 4 minus 1, 4 minus 2, 4 minus 3 and 4 minus 4. So this becomes 4 minus 1 3, 4 minus 2 2, 4 minus 3 1 and 4 minus 4 is 0. As we have taken delta equal to 6 because we are going to predict the 6 future samples. So just simply putting the values of delta here, we are getting xt minus 3 into 6, xt minus 2 into 6, 1 into 6 and 0 into 6. So we get these 4 previous values of our time series xt. So we'll take xt minus 6, xt minus 12 and xt minus 18. So we will provide these inputs to the ANFIS to predict the future values xt plus 6. So obviously the 6 future samples will be predicted by this model. So when we will initialize the ANFIS, we will create a input-output data matrix. So in that data matrix, the first 4 columns will be these, these inputs, xt minus 18, t minus 12, t minus 6 and xt. And the last column will be this xt plus 6, that is the output. So again, I recommend you to watch my previous video so you can understand that what is the input-output data matrix that is used for training ANFIS, okay. So this is now you can see graphically. So this is my series xt from index number 118 to 1117. Okay, so this is xt minus 6 from 112 to 111. So these are all our 1000 points. Then this is xt minus 12 starting from 106, and this is xt minus 18 starting from 100. Okay, and this is the output xt plus 6, which is the output of ANFIS. So that will start from the index number 124 to 1123. Now see how I am predicting the future values. So what are those future values? Actually to the ANFIS I am giving only following inputs. So xt minus 6, t minus 12 and t minus 18 all are past values. Okay, and up to 1117 index I am giving to the ANFIS. But ANFIS output is up to the 1123 index number. So what does it mean? So it means that from this 1118 to 1123, these 6 samples are the future samples, because that is the output of the ANFIS. We have not given these 6 samples as input. We have given the inputs up to only the 1117, but we are getting output up to the 1123. So this is how my ANFIS will give me the 6 future samples. So let's see the simulation results. Later I will show you the MATLAB implementation, MATLAB code, and then actual simulation in the MATLAB. So following is the ANFIS output, which is plotted with the input MG series, and you can see both are overlapping. So this graph is showing me the actual MG series and the ANFIS prediction. So actually these are the 2 curves, okay, this is not a single curve. So actual MG series and the ANFIS output. So here you can see that it is almost a perfect overlapping. So that means the ANFIS prediction is quite good in this case. Although there is a difference, when I will zoom it, then you can visualize the difference between the 2. And that is very, very small in the milli order, 10 power minus 3. So prediction is quite good. And following is a prediction error. So this is the error actually, what I was talking about. Although both the curves are looking overlapping with each other, but actual difference is this. Okay, so that you can see only by zooming, and you can see the magnitude also, as I was talking about, the difference in order of the 10 power minus 3. So that is quite good output. And these are the predicted 6 future samples you can see. So the first one, second one, third, fourth, 5th and 6th. So the blue one is showing me the actual MG series. So these are actual points of the actual MG series, and these 6 are the prediction points. So you can see their differences, in the values. So this is the actual one, that is 1.0994, and this is the output, predicted output, that is 1.0982, and this one is actual one, that is 1.9550, and this is the predicted, and that is 1.0946. Similarly, this is actual, and this is predicted, actual, predicted, actual, predicted, actual, and predicted. So you can just compare the magnitudes. So they are very close with each other. The difference is very small, of the order of 10 power minus 3. So you can see the prediction is quite good. In the first image, both the series were looking overlapping with each other. So here you can see the zoom part. So there is a difference, okay, though it is very small. So but there is a difference in prediction and actual points, but the prediction is very close to the actual. So now let's come to the MATLAB code. Later I will show you its output running in the MATLAB. So this is my file. First I am loading the MG series, okay. So I am loading the XT. Fortunately it is already given in the MATLAB, so there is no need to take from outside. So when you load mgdata.dat, you will get all the 1201 points of this series in the workspace. So here I am separating the x-axis value and the y-axis value. Time, that is the x-axis, and then x and time, so that Mackey-Glass series, okay. And here I am plotting this series. So first plot you will get the simply MG series plot. Now I am creating the input output matrix, as I said in the previous, as I explained you in the previous slide. So here in this input output matrix, the first 4 columns are your inputs, and these inputs all are the previous values of the series, and the output, 5th column, is showing the output xt plus 6. So this data matrix, input output matrix, you have to provide for ANFIS training. Then out of this, the training data is taken as the first 500 rows, and the remaining 500 rows are taken for validation. So now we are creating FIS here with the GenFIS function. So that this is input, this is output, and GenFIS options. I mean, we are taking the grid partitioning for initializing the membership functions for this GenFIS. Now we are defining some options like initial FIS is FIS. I mean, this is the created. This is created here, and we are providing the validation data. So validation data is val data, that is defined here, right? I mean the remaining 500 points in that data, not points, remaining 500 lines, rows in that input output data matrix. So now the training of ANFIS starts by this command. So ANFIS, train data, and then options. So these options will be used. I mean this FIS structure will be taken and the validation data will be taken. And the training starts. So you can see the MATLAB workspace, the progress is printed there. I will also show you. So your output, I mean your trained model is obtained in this variable FIS2, right? So now once it is trained, everything goes into this FIS2. So I can evaluate this FIS with my input data. So now I am evaluating this trained FIS with evalFIS function. So I am providing the input data, input, and then training data, and then validation data. I am taking column 1 to 4 only. 1 to 4 because, as I said, in the data matrix, the first 4 columns, 1, 2, 3, 4, I mean xt minus 18, t minus 12, t minus 6, and xt. These are inputs, and the 5th column is output, that is xt plus 6. So output is given only in the training. So now we are doing the evaluation. So obviously we have to give the inputs only. So this will be obtained as the output. So that's why we are taking all rows and columns from 1 to 4, only these columns, right? So after evaluation, the output, I mean the predicted series goes to this variable ANFIS output. So here we are taking index 124 to 1123. This I have already shown in that previous slide, that the output xt plus 6 will start from the index number 124 to 1123. And since we have taken series, I mean xt from 118 to 1117, and we are getting output up to 1123. So from sample number 1118 to 1123, we are getting these 6 samples as output. I mean here it is shown, index 1 is showing this index of 6 future samples. So now we are plotting the input series X, that is MG series, actual MG series, and this is the ANFIS output. So you will see both the input and predicted output simultaneously. And in third figure, you will see those 6 samples, predicted samples, right? And in figure 4, you will see the error curve, I mean training and validation error curve. And in fifth figure, you will see the difference between the actual MG series and the ANFIS output. So now let me run this program into the MATLAB. Then you can see the actual outputs. So I am jumping to the MATLAB. Okay, so this program I have already written here. So I will just press this run button and let's see what output I will achieve. So it is run. Okay, so this is my workspace. So in the workspace, you can see some parameters like ANFIS info. So here you can see that number of nodes in the neural nets are 55, number of linear parameters are 80, nonlinear parameters are 24. So total parameters are 104, which are tuned during the training. Okay, so what are these linear and non-linear parameters? This you can understand in my previous video if you go through that. And training data points are 500, validation points are 500 as we have already taken, and the number of fuzzy rules are 16. So you can see the start of ANFIS training, and here you can see that error is reducing. So after the training, you can see that minimal training RMSE is 0.0025. So that is quite good. So now let me show you the curves. So this is the first one. This is simply the plot of your MG series, right? All 1201 points. And the second plot is, okay. So here we have plotted the actual MG series and the ANFIS output, predicted output. So this is actually showing the 2 plots. So they are looking like one because they are overlapping with each other. So this I have already shown you in my slides. So if you zoom it, you can see the difference. So let me zoom some part of this series. Okay, so when I zoomed it, you can see the difference between red and blue. So your blue is original and red is predicted output. Okay, so that is a difference, but this difference is very, very small. And now let's see what is the third one. Okay, so here you can see all the 6 predicted samples. So these blue ones are actually your actual input. I mean the points of your actual input series, and while the red points are the predicted future samples. This I have already shown in my slides also. And this is the error curve. You can see both training error and validation error with respect to the number of epochs in the training. So that is a RMS error which is going down, and in the order of milli you can see 10 power minus 3. And the last one is showing the difference between the actual input MG series and the predicted MG series. So that's a difference. It's a very small difference of the order 10 power minus 3. So this is actually the overall process of time series initialization. and the time series prediction. So in this particular example, we have seen the 6 feature sample prediction. You can change that value also. So the formula I have already given. So instead of keeping delta or p equal to 6, you can keep 4, 5 or even more. So that depends on your requirement. So that's it for this video. I hope you have enjoyed it. You have learned something new. So as we know that ANFIS is really a very powerful tool. So in previous video, I have shown you that how ANFIS can mimic itself to realize any mathematical function. So in this particular example, we have seen that how ANFIS can be used to predict the future values of a time series. So thank you very much for giving me your precious time. I hope you have liked this video. So please like this video and share this video to the maximum. Subscribe for more such interesting videos. So thank you very much once again. Have a nice time.